Okay, so now we will be discussing prime factorization. Now, before we move into it, we need to know two things before we move into prime factorization. And that basically is the prime numbers and the composite numbers. And what exactly are those? Now, first of all, we will start with the prime numbers. These are the numbers which have exactly two factors, and these are called prime numbers. Now let us get into the examples. We have the number 2, the number 3, the number 5, and 7, and 11. All of these are prime numbers, and I'll show you why. Now 2. What are the two numbers which you multiply, which are basically the factors of 2? There is 2 and there is 1. 2 times 1 equal 2. Same goes for 3 and 5. All of these have exactly two factors. What I am making right now is called a factor tree. 11. Now, these are called the prime numbers. Now remember the one condition. This term is only applied to positive integers. This term is applied for only positive integers. Now let's get into the composite numbers. Now what exactly are composite numbers? These are all the numbers which are not prime numbers. Now there are two conditions for it. One cannot be included, and the term is only applied for integers. Now, for example, 4 is a composite number. You know why? It has actually 3. Yes, 3. We have 4, 2, and 1. 3 factors. More than 2, 3 factors. Now this is a composite number. We have 8. Now 8 has 4. Wait, let's see how many factors does 8 have. 1, 2, 3, and 4. 8 has 4 numbers. Now we are ready for prime factorization. Now what exactly is prime factorization? A prime factorization is when a composite number can be represented by the product of prime numbers. This is actually prime factorization right now in front of you. Now let's actually do some problems. Now we have the number 45. We want to have it prime factorized. Okay. Now what are we going to do? We are going to take the composite number and we are going to reduce it to prime numbers. Okay. 5 times 9 equals 45. Now we can't actually reduce 5, so we are just going to write 5 times 1. We can reduce 9, 3 times 3, and there you go. Now this should be written as 45 is equal to 5 times 3 times 3. Exactly fits the description. When a composite number can be represented by the product of prime numbers. We do another example. 30. 30 can be written as follows. 5 times 6 is equals 30. We can reduce 5. We can reduce 6. 3 times 3. So wait, what? No, 3 times 2. 3 2 6. Okay. So 30 can be written in its prime factorized form as 5 times 3 times 2. 5 times 2 10. 10 times 3 30. Okay, 30 is equal to 30. Another short example before we end this video. 5 times 2 is equal to 10. So when you have to write 10 as in its prime factorized form, you write it as 5 times 2. And that is all.